In this BimlFlex session, we're going to be looking at Snowflake Data Warehouse Automation and specifically focusing on using natural keys, business keys, or what I would call an integration key, and how we can actually create a parallel process and load your Snowflake Data Warehouse in the fastest way possible by using all the parallelism that's available to us. The first thing I would like to point out here is a disclaimer, and this is something that I heard said at the latest conference that I was at, Data Vault conference I was at, which is just because you can doesn't mean you should. And what I mean by that is that using an integration key without hashing the integration key and using that approach, you will get the fastest ETL or ELT pattern possible. But it doesn't mean that that is the right fit for your requirements. So please make sure that before you actually take the fact that you can do this and just say, well, I want the fastest ETL pattern, make sure that you know everything else that goes with that. In other words, whether it can use the personal information and all that kind of stuff. So just bear in mind is that this is focusing on actually the pattern and the fastest possible pattern, but just bear in mind you need to make sure you can understand the impact of that. Let's have a quick look at Snowflake Automation in the context of BimlFlex. I'm just going to briefly touch on this so you know what's coming. We're going to be importing metadata from source files. I'm not going to focus on that a lot because that's covered in other videos. The metadata sits in our metadata repository, and then from there we can do data vault acceleration, business rules. We can do a whole bunch of stuff, which again is covered in more detail in other videos, but I'm not going to focus on that a lot today. What I am going to be focusing on is the fact that building the Snowflake ETL pipeline or ELT pipeline, we're going to grab the data from the sources, land it into a staging area, Snowflake stage, data lake, whatever. We're going to focus on Snowflake for now, Snowflake stage. From there, we're going to load it into a staging database. You can optionally switch on a persistent staging database if you want, or persistent layer. But from there, we're going to move it into the data vault layers here. We're not going to be focusing on all the different data vault options because, again, that's covered in other videos in more detail. We're also, in this case, not going to be focusing on the dimensional part of the Snowflake implementation. Again, also covered in other videos. So the first thing we do is let's have a quick look at an overview of what this would look like. The first part of the process is going to be we need to get the data from the source and put it into a file system like Snowflake Stage. So Snowflake Stage will take care of most of the plumbing for you, so you don't have to worry about, oh, is it Azure Blob Storage, is it Amazon A3 or S3, sorry. It'll just cover that all for you, so you just choose Snowflake Stage. But what we're going to do here is extract the data from the source. We may need to do some preparation, like standardizing the date formats. If you got all different kinds of source systems there, they'll have different date formats. We'll prepare the dates. And then the next thing we want to do is we want to make sure that we create as many files as we need for a parallel process. I'll cover that off a little bit later on again. And then as we upload it, we can choose to, we have options to compress that data and send up a compressed file. Instead of setting up the whole file, you send up a compressed file, which again will cut down on the network latency. We will use SnowSQL to copy the files into Snowflake Stage. Again, that's the best process that we found so far. And then on the flip side of that, once the data is sitting in Snowflake Stage, we will use the copy command from Snowflake to load the data, obviously first into a staging layer, but the data will be used from the Snowflake copy command. We'll go in through a staging layer, and then we will load it again as parallel as we possibly can with settings into our raw data vault or into our data vault. And then we can also later on, which we're not going to cover in this session, we can add point-in-time tables, breach tables, etc. sitting in our Snowflake data warehouse. And then from this point onwards, really you can decide to either create a virtual data mart or a physical data mart, depending on what you need, and then providing your business with analytics and really get that through as quickly as we can. So let's have a quick look at the different data vault options here that we're talking about. So we're talking about using integration keys instead of hash keys. Integration keys will be more performant from an ETL point of view, and hash keys, because the hash key, obviously we need to do the hash algorithm, the SHA-1, the MD5, or which other algorithm you choose to obfuscate the keys. With using the integration keys, we also then can have virtual hubs, and which is quite interesting because if we're putting point-in-time tables in place to enable our virtual data mart, the point-in-time table effectively becomes a pseudo hub, so we can actually still have the hub entity there, but it'll be a view. So you can create what we call a virtual hub, and then we'll touch on that, possibly not in this session, but it's an interesting concept there. What you need to understand is probably the key thing about using integration keys or natural keys, business keys, etc., is that because the key is now stored in the satellite and in the link and in the hub, if you have a hubs, the integration key is in the satellite, that may not be compatible with personal identifier information. So you need to make sure that if you choose this option, that you either have some other way of actually storing secure or sensitive data, and make sure that it conforms to whatever your compliance is. And then on the BimlFlex side of things is what we really want to do is allow the customer the flexibility to switch to Snowflake deployments quite easily. So again, allowing you the ability to use HashKeys or not gives you the best option and choice when implementing a Snowflake project here. And then accelerate your projects. I'm going to take you very briefly through this, but you can do a Snowflake end-to-end proof of concept in as little as a week. You can do it quicker as that, but if you want to do that, and then even with your own data, choose and switch between using, integration keys or natural keys and hash keys, we can easily and I'll show you in a second how quick and easy it is to do that. And then the last one is the ability to customize and extend. You want to have a framework that does, that has that standard templates with it for you, but have the ability to extend that out. We're not going to cover out on that customizing extends in this session, but we definitely make sure that you have the ability to get in there and do it. So again, let's have a quick look at something I'm going to show you. So this is the the sample database that Snowflake also use. So what we do here is, and this is just output from our accelerator. I'll show you this in a second here. But what you have on the left hand side here is you have a source table, and on the right hand side here we have a target data vault structure here. And what we want to do here is we want to obviously map the source to the target. I'm going to show you that a little bit here, but as you can see here, this _SK means that we're using the surrogate keys in this. And again, I'm going to show you how this. But loading this data vault, and what you need to do is, as I said, we're going to drop the files into Snowflake Stage and go through the staging database. That is kind of compulsory. In there, what we do is we prepare all the data and all the hashes. If you're using the hash keys, that's where all the hashing will happen. And then from there will be a ETL load that loads all of this data into the hub, the link, and the satellite. By the way, these guys over here is what we call inferred hubs, which is not required, again, if you use natural business keys. But what these are, again, is an option that if you're loading your link, you may have, business keys that you are deriving surrogate keys from in that link that may actually be missing in your source system. So we have an option there to say, you know what, just go and check that these surrogate keys that I'm loading, that they actually do exist in my hub. Okay, so that's why these are here. Now in the natural key using the integration key, this will actually not be there. So again, there's another part of the process that just is not required. So possibly if you're using virtual hubs, this would look like it'll have in a physical structure would be, there'll be a link and a satellite. There'll be no hubs. There'll be virtual hubs. So there'll still be hubs, but there'll be views. There'll be virtual hubs. The second thing you want to do with loading into Snowflake, and this is where when we did our analysis of which tool sets we use, one of the key things about using Snowflake Settings is being able to load files in parallel. If you're going from your source and you're extracting, let's just say, a terabyte worth of data, which I know sounds a lot, but we regularly have customers that does this. If you want to load it into a single file, so let's just say, let's just make it simple, a one gig file, right? So you're taking a gig's worth of data and you're loading it into a single file. You then load it into Snowflake. Snowflake can only load that one file at a time. However, what we will do with BimlFlex is we will split this file across as many files as you want. So you can choose at an object by object basis, or even at you can say all of the files in a certain connection. I want to split them up into 4 or 8 files or 12 files, and then your bigger files, you can split them up into further parallel processes, allowing Snowflake the ability to load the files on the flip side also in parallel, giving you the most optimal way of actually getting your data into Snowflake is to use multiple files. So this is one ETL pattern or one file that I'm loading. So if you can imagine, Snowflake will do this. You will extract your data, put it into Snowflake Stage, go and stage it and load it. So think about this as a micro batch of one bit over here. You may have a second file and a third and a fourth. You may have 100 tables or files that you need to load that goes through a Snowflake process. So think about this as a micro batch. But what if you want to load your data in as parallel process as possible? Now, Snowflake, what's great about what they've done is they've actually separated the compute from the storage. So what you can have is you can spin up as many compute data warehouses as you need for your ETL and use different compute data warehouses for your reporting layers. So what you could do, or what you want to do, is you want to work out the best, performance side of things, and possibly have your one set of files or one file sit on compute warehouse 1 and one compute warehouse 2. So you also want to have your automation give you the ability and the flexibility to be able to split your source system. So if you're extracting 100 tables from one source, you may want to extract 20 files from using one compute warehouse and 20 files from a different one, and then the rest, all the small ones, the 60 or whatever is left, in a completely different compute warehouse. So you want the ability to configure how many of these compute warehouses you use. And then the second thing you want to do also is the ability to potentially scale up the compute warehouse and scale down the compute warehouse at the end. So the ability to kind of stop and start things automatically, so you can also reduce your cost. So let me go straight ahead and go into BimlFlex Demo and just show you how all of this stuff hooks together. All right, so in BimlFlex, what we have is I'm not going to focus on importing metadata and really the detail of the Data Vault acceleration. That detail of how do we use Data Vault acceleration is covered off in other videos. I'm going to focus purely on the difference between using a HashKey and an integration key. So the first thing we want to do here is, if we just go to our Data Vault accelerator here, and I'm just going to pick one table here, again, we'll accelerate the whole thing. What you'll see here is, and I'll just fill this out, is just by a very standard Data Vault acceleration here, we're going to get that, hubs and links and stuff. And what you'll see here is I've got the surrogate key. And if I'm just going to go ahead here and just show you the data types here, you'll see that these are, string. I've got, what I've set here is I've set to use SHA1 hashing, and to hash it not in binary format, but hash it into a string format. Again, very easily to change that if I go into my settings here, and I'm just going to go and filter here on the word hash, which gives me, all the hashing. So if I go to hash binary, which is set to no, if I set that to yes, and I save that, if I come back into my accelerator now, you'll see that now I'm using var binary 20 here. So now I'm doing binary hashing. So that's the first bit of it. If you wanted to use hash keys and to use binary hashing, that's what you will do. You can switch between character and binary hashing. You could also, as I said, on the settings tab, I'll just filter it again on hashes here. If you're hashing, you can also go and use what hash algorithm you want to use. You can use MD5 there, SHA-1, SHA-2, 256, 512, depending on which hashing algorithms you want to use. So that will give you the BimlFlex, will then now build out your Snowflake options there using integration keys, using hash keys. But if you want to use integration keys or business keys to do the hashing, we have this Data Vault use hash key, which is set to by default to yes, because that is the most popular or common pattern at the moment. If I set that to N for no and save it, by the way, this is all you have to do to switch between the integration keys and the hash, using hash or using integration key. And now what you'll see is, if I'm coming in here, let me just refresh this. Now, instead of using my business keys here, I'm using my integration keys, my hash keys here, I'm using business keys here. So that's all I need to do. So from a Data Vault acceleration point of view, you go through the same process of doing a Data Vault modeling, and then really all you need to do is go and change that one setting. And by purely changing that one setting, you get everything you want to do. So all I'm going to do here right now is I'm going to go and, again, I'm not focusing on the Data Vault's acceleration here. And obviously we do not recommend that you just wizard up or forward engineer a Data Vault. There is quite a lot of Data Vault modeling that you want to do. But for the purpose of this video, I'm just going to go and select all, get my entire Data Vault modeled here or accelerated here for me. And I'm just going to hit publish. So this actually takes the logical Data Vault model that I've just built and modeled. I can review it, I can print it, and I hit the publish button here. And if I hit the publish button, I now get my target Data Vault. So I get all of the source to target mapping. So if I go into an object here and I look at just one of the source objects here, you'll see here's all my Data Vault objects here. If I look at any one of these tables here and at any one of these columns, you'll see here that I'm going to my target object of a link satellite here. So everything is now forward engineered, and the source to target mappings is in place, and I now have my integration key logic built. I can now go ahead and build this out, right? But let me just show you a couple of those things that we touched upon. The first one is, for my entire source system, we need to decide how many files do I want to create for parallel loading. And it's very simple to do that. Is all I need to do here is go to threads and decide how many files do I want, how big is my, I suppose, my most common tables. And let's just say my most common tables, you know, I'm going to split them up in 4 files and use 4 files as a priority. I can just change this to 4 here. So I can go this to 2 or 4. And now I can decide how many parallel files do I want to export. I can also go into my larger table. So let's just say my line item here is the larger one of the lot. On this, I can actually go on this one and say, well, for this one, I want 8 threads. So instead of everyone is going to have 4 threads, but for this one, I know it's very wide. I can make it 20, 24, however many threads you want or how many files you want. And I'm going to go ahead and hit save here. So now I have all of my files, will export from the source and land it in 4 files, except the line item. We will land it in 8 files. So we have that maximum parallelism at the extract layer. The next thing we want to do is on the loading on the flip side of things. So again, I'm not going to go into too much detail here, but I can actually go into my data vault, and actually what I need to do is I'll first need to create a secondary project. So think about this, is that you want to separate your loading into 2 separate projects, or 2 separate batches, because I'm going to have 2 different compute warehouses is going to load my data. So the first thing I want to do here is create another batch. So again, I'm just going to base it off the one that I have, which is this one. And I'm just going to go ahead and duplicate this one. And I'm just going to call this, SF underscore load underscore. And I'm just going to make it 2. Just so that's my second one. I'm actually going to just copy this because I know I'm going to need this in a second. And I'm just going to copy this. And again, I'm going to leave that. And by the way, at the batch level here, you can also decide how many processes do you run in parallel. So on the connection, you say how many files do I want to export, and then at this level here, I can say I want to load 2, 4, 6 files in parallel. Okay, so I'm going to leave it at 2 here. Actually, in fact, I'm going to make this 4 here, just to be different. So I'm going to have 4 threads here and 2 threads here. All right, so the next thing we need to do here is, and the best way to do this is to think about this as the hubs, the satellites really determine which batch it belongs to, because the way that BimlFlex figured out, it first looks at the satellite to see which project the satellite's assigned to, and it'll assign it there. So I'm just going to grab, this file here, and I'm going to just move this one. Again, there's more work that can be done here, but I'm going to, also need to create a second project. So I'm going to go in here, duplicate this project, and I'm going to give it the same name as that. And on that project, I'm just going to go and give it the batch of this. So now I've got 2 projects, 2 batches here. Actual fact is, I will duplicate this one again, and I'll make this batch 1. Project 1, I'll make it. It'll all make sense in a second. What I'm going to have a parent project that has 2 child projects here. But the second thing I'm going to do here is just go to this batch. And actually I'll just rename this one to _1 and save that. Okay, and at the project level here, I'm going to go ahead and on this one say that the parent project here is this one. So now I have that structure between the project and the parent project. And again, I'm going to go and set that one to this and save that. And this guy here, I'm going to make that 1. Okay, so long story short is I have a parent project and child projects now. So that's just going to be, so they are still grouped together under my data vault load here. And then all I now need to do is go and change the, basically switch these guys out to a different project. So I'm going to make that part of project 1. Okay, and I'm going to go back here to this guy, and I'm going to go and switch out, switch out this guy. I'm going to put this one into project 1 also. And I'm going to do this I'm going to split this for the rest of these guys. Okay, so I've just gone ahead and just switched these all out. So as you can see here on the project 1, I have these satellites. On project 2, I have these satellites, and the hubs and the links I've just left in this one here. It'll figure itself out where they need to load from. So don't worry about it too much there. Actual fact is I'll go ahead and just take this one and switch this one out to project 2, and also its associated link, which is going to be right about here. Just going to take its associated link also and put it into a different project here. So I think I put it in 2. Let me have a quick look. And great, so I've got these guys here. So effectively you can go and mix and match and switch all these things. We also have an Excel add-in that allows bulk operations. So for this task here, I would have probably used the Excel add-in because it's a great, a lot better there. So what I'm now done is I'm going to switch over to Biml Studio, which is the tool that we use to do the development and the building out of the project. But you can also obviously totally do continuous integration with that kind of stuff here. So let me just switch over to Biml Studio and open this project up and take you through the loading of. Right, I'm just going to briefly take you through what we've just built out, and we'll cover this later on. Again, if you look at just the connections here, what you'll see from the configurations, you'll see that I've got my 4 flat files for everything, and I've got my 8 flat files for the line item, as you can see here. So that was what that one configuration was done. You'll also see here that I have my 2 batches, my RDB1 and my RDB2. So those are my 2 parallel processes, and I can go and configure them to be in separate compute warehouses. Again, I'll show you that in a second here. And here are all my extract packages that's going to be created. So my source to extract packages. So I'm just going to go ahead and build this out and then open that up for you. So I'll build this out, but then I'll switch back over to BimlFlex and just show you where all of these settings and configurations are for you to go and configure this parallel load in any which way you want. All right, so now back into BimlFlex, as you can see here, here's all my data vault objects here, but I'm going to go and just look at the settings here. And again, what you'll see here is if I just look at the group here, I'll just group it on Snowflake here. And okay, great. So as you can see here, there's a whole number of settings here. The first one is the, where is my Snowflake SQL? So where is my config file? In that config file, you would set things up for SnowSQL to work. The database connections, your SQL connections, your account that you're using, your database, your passwords, which I'm not going to show you here. But also what you have here is the ability to scale up. So you can go and scale up. You can decide to scale up or scale down. And again, these things, you can add them. But just to give you an idea here, auto suspend, what's the file format? Well, you want to remove the staging after you've loaded it. But all of these settings here, you can have a global setting, or you can have a more control setting. So just looking at scale up here, whether you want to scale up or down, and what is the size that you want to scale up. So you could have this set to medium, but you can also then go ahead and add an override here at a batch level to say for a specific batch that you want to choose here. Let's just choose this one. I want to say that this scale up size here, instead of being medium, I want to make that large. So you can control things in this context here where different compute warehouses and different batches can scale up to different sizes and scale down. So all of those settings can be controlled. And I'll save that up. So I'm not going to go into showing you all of these switches here. We can cover that off. If you want to do a proof of concept, let us know. We can do that. But let's go and have a look at the output of the code that we've just generated. Okay, so first let's have a look at the batch file that was generated to extract the data. As you can see here at the top of the batch file, we have the ability to scale up. So again, right at the start of the batch, you can scale up your compute data warehouse. You can scale up multiple compute data warehouses to create that micro batch layer here. And then we will call our extract packages here. Again, you can have these run in parallel also. So you could also at the source to staging layer, you could also go and split those up into parallel processes if you want. We've kept this in series here. So the first one here is you can scale up at the beginning, and then you can scale down when you're done. Again, you also have the option to not scale down and leave the computer warehouse running, so that it can load the data vault projects straight afterwards. So you don't have to scale up, scale down, and scale up and scale down. Again, you can choose which batches have them and which don't have them. But at the line item here, and the reason we're using SSIS for these things here is one of the key reasons we're using it is because other ETL tools we haven't found one that actually gives you the same ability to use this sort of parallel processing where you can actually expand to many files here. So if you can get around the fact that yes, we use SSIs to extract the data and land it, but from that point onwards, at the moment we're only using SSIs as an orchestration tool for Snowflake. We are looking at other options going forward for our cloud deployment environments here. So we can go ahead and run this, and again, as I said, we're going to run many flat files out. So once we've run that files, I'm not going to run it right now, but again, as you can see here, we can have all of that parallelism at the export level here. If I were to open up the customer one here, you'll see that I only have the 4 files going down here instead of the 8 files. So that gives you that flexibility to tweak how much parallel files you want to do. The next thing is, let me go and open up the batch that is going to load the data vault now for us. Okay, so let's have a quick look at the batch files that was created by BimlFlex. The first one here is the batch file that I specified to have 2 parallel threads. At the top of the batch, you'll see a scale up, and this scale up will actually execute a command. So if I just quickly have a look at the command here, just to give you an idea of what's going to happen here, let me paste it here. As you can see here, it's going to go to my data warehouse, it's going to resume it if it's suspended, and it's going to alter it, and it sets the size to medium here. These are the configurations that you can do auto suspend, and the warehouse size that you can configure. Also at the end, so that starts at the beginning of the batch file here, and then at the end of it you can switch it off. You can also configure it in such a granular level that you can start the batch file, start your warehouse in this batch, and not switch it off in this batch. You can say don't scale it down, because you might want to use that compute warehouse for multiple batches, and you want to only switch it off in the last batch. So you have all of that ability to switch it off there. If we look at the second batch file, again, you can look at this. It'll scale up your second compute warehouse, and this is the one where we said we want to actually execute 4 processes in parallel. You can have all of your processes in parallel, but in this one, we've said we want to only run 4 batches in process here. And I'll just grab the code for one of these guys here. So I'll just go to this one just randomly and grab the code for that. And as you will see here, if I just go in here and paste it, you'll see this is all of the code needed for using that one supplier source table and loading the hubs, the links, and the satellites here. So all of this, the Snowflake code is all created for you, and it looks like a lot of code, but because it's doing quite a lot of stuff there in the satellites, it's doing ABA checking to make sure that we're not collapsing, we're having collapsing all the data as we can based on your splitting of your satellites. What we are going to be working on, or what we are working on at the moment, is adding this execution here, the ability with another setting to have this execution as part of your staging load, so you can go source to staging, and then straight from after you've staged your data, you can actually execute the data vault package for that. So that entire micro batch, all the way from your source all the way to your stage, to your data vault, is done in a single micro batch or a single flow there, giving you even more parallel loading capability. So I hope you enjoyed the demonstration of how you can use BimlFlex to create what I would call extreme parallelism with the Snowflake environment. If you want to run a proof of concept, please feel free to, that's my Twitter handle, or contact sales@bimlflex.com, or go to our website, bimlflex.com. Please let us know. We'd be happy to work with you to do a proof of concept and show you the difference between both, obviously, the ability to run those, configure those parallel processes, but also the ability for you to easily switch between hash keys and integration keys, and then you can actually do this on your own data to see the performance differences in the 2 approaches. Thank you for your time, and I hope to see you in the next video.